Fractions are numbers, just like the whole numbers, and we understand adding them in exactly the same way. So recall for a moment that we understood the sum 2 plus 3 equals 5 on the number line in this way. The number 2 is represented by this line segment starting at 0 and extending out to 2. The number 3 is represented by this line segment starting at 0 and extending out to 3. And we represent the sum 2 plus 3 by drawing the line segment 2, and on the end of that line segment, adding on the line segment 3. And we see that those add up to the line segment starting at 0 and extending out to 5. 2 plus 3 equals 5. We understand addition of fractions in the same way. So notice that this number line is different from this one because its units are larger, and I've done that intentionally to be able to look at fractions. Here we see the fourths. So for example, this number is 3/4, counting 1, 2, 3, which means that 3/4 is represented by this line segment. Its length is 1/4, 2/4, 3/4, all put together. Meanwhile, the number 7/4, 1, 2, 3, 4, 5, 6, 7/4, is represented by this line segment, starting at 0 and extending out to 7/4. How then do we understand the sum 3/4 plus 7/4? Well, we take the line segment 3/4 and then we pick up the line segment 7/4 and set it on the end. So the length of this line segment will be 1, 2, 3, 4, 5, 6, 7/4. Where did that take me to? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10/4. 3/4 plus 7/4 is 10/4. These two line segments together combine to give me the line segment 10/4. What did we just do? We just added together the numerators and kept the denominator the same. Does that make sense? Well, yeah, right. We have these things named fourths. They are little line segments of a certain length or little pieces of a certain size. We have 3 of them and then a further 7 of them. If we put them all in a pile together, they're still the same kind of thing. They're still fourths. We just have 10 of them. So this suggests a general procedure, right? Because if our pieces are a different size, nothing's going to change. Our general procedure to add like fractions. What do we mean by like fractions again? That means the same denominator, the same kind of piece, the same size little line segment, the same kind of fraction. To add like fractions, we will add the numerators and keep the same denominator. So I'm going to have you try one of these with drawing the number line. Add 2/3 plus 5/3 and justify your answer by drawing line segments on a number line. Pause the video and try this now. Alright, so we're going to start with a number line, and we're going to draw in the thirds by splitting each unit into 3 equal parts. Remember, making 3 parts requires 2 cuts. Now we'll draw the line segment 2/3, 1, 2, and the line segment 5/3, 1, 2, 3, 4, 5. What will 2/3 plus 5/3 be? Well, we'll start with our 2/3, and then we'll add 1, 2, 3, 4, 5/3 onto the end. What does that add up to? It adds up to 1, 2, 3, 4, 5, 6, 7/3. 2/3 plus 5/3 gives me 7/3, which is what I would predict if I just added together the numerators. Now I'm going to give you one to try that is inconvenient to draw on a number line. Add the fractions 29/87 plus 124/87 without drawing out the sum on the number line. Pause the video and try this now. Well, the things we're adding together are all 87ths. So our answer is going to be some number of 87ths. How many? Well, 29 of them plus 124 of them. So altogether we'll have 4 plus 9 is 13, 1 plus 2 is 3, plus another 2 is 5, and that's just 1. So we'll have 153 of them. Also notice, sometimes we can simplify a sum. After a little bit of thought, I noticed that 153 and 87 are both multiples of 3. 8 plus 7 is 15, a multiple of 3. 1 plus 5 plus 3 is 9, also a multiple of 3. I can do that division. 3 goes into 153. 3 goes into 15 5 times. 3 goes into 3 once. So we'll have 3 times 51. 3 goes into 87. 3 goes into 8 twice. 3 goes into 7 9 times. Cancel the common 3, and we're left with 51/29. Still not very nice, but simpler than 153/87. 29 is a prime number, so we can't simplify that any further. Do we need to simplify a sum? Not necessarily, but you should be aware that sometimes we can. So I'm going to give you one more of these to try, with the instruction that you should simplify the sum. Add 11/9 plus 19/9 and simplify the sum as much as possible. Pause the video and try this now. Alright, the things we're adding together are all ninths, so the result will be some number of ninths. How many? Well, 11 plus 19. 1 plus 9 is 10. 1 and 1 and 1 is 3. So that'll be 30/9. Looking at these two numbers, I see that both are multiples of 3. 30 is 3 times 10. 9 is 3 times 3. So, simplifying, this is equal to 10/3. Only after simplifying will the denominator ever be different than my original fractions.